Hello and welcome to Hillcrest's short video on how you can potentially upgrade your wiring on your engine, whether it's marine or rail traction, from a solid system to a flexible system. Here we have a Ruston RK 270 16-cylinder rail that's been in service. Now, as you know, these will be very expensive to ship. Very difficult to repair, and all sorts of associated problems with fitting them onto the engine, etc. So this here, what you can see now, is how Hillcrest proposed to exchange this system, and this system is covered in aramid fibre, which is, as you probably more know, as Kevlar. The sockets can be, and the harness can be, clipped to pipework. Ideally, we recommend that you use a tray system, of which we have several varieties shown here. We have a larger to take bigger harnesses and a smaller to take smaller harnesses. They can be mounted vertically on the side or inverted. We also recommend the use of fixing brackets. The fixing brackets can be made to attach to existing engine fixings. In this particular instance, these are designed for a customer to go onto the camshaft doors, and they have resilient Viton mounts to aid with the problems of vibration. They can be fitted anywhere on the engine, and as you can see, the trays are slotted, A for a certain amount of clearance and movement with the engine mountings, and also for clipping the harness. Main differences between the flexible harness and the solid harness are this is a powered circuit. We convert all signals to 420 to 20 milliamps, and all the connectors are female, so this avoids any risk of the pins shorting out and causing problems to the power supply. It is possible to do things using the existing connectors, but then you need to have protection circuits for your power supply. The outlet in this particular instance, this is a similar size harness of a slightly smaller engine, and being 4 to 20 milliamps, only one wire is required for each signal, and the power supply is common. And the measurement is then done in the return signal. So just to give you a quick idea, this on this Ruston engine, this is Mark II sensor, and this is a Mark I sensor. Both are interchangeable, and we can make this type of sensor with the male connector, or we can take stock and put your male connectors onto, if you had large quantities of stock, we can convert them so that they will be suitable with our transmitters. To show you now with the transmitter, this is another engine manufacturer's sensor, and this is fitted with a signal conditioner, 4 to 20 milliamps, and this particular one has the facility to do onboard calibration, which I will demonstrate now. So to calibrate this sensor, the sensor is fitted with a switch, and you need a 2.5 Allen key. The 2.5 Allen key will close the circuit, at which point you cannot calibrate, at which point you open the circuit, and now you can calibrate. So we now are injecting 800 degrees centigrade millivolts. So if we try initially to do 0 centigrade, so we have 4 milliamps at 0. We will then correct the 800. This is how easy it is to do. So we then adjust the span pot. As you can see, very easy. There we go, 800 degrees C, 20 milliamps. The sensor is in the diagnostic position, so we go back to 0, 4 milliamps, close the circuit, calibrated, job done. The other alternative is to have without the switch version, and you can see that the actual case is smaller. It's not possible to do a diagnostic test on this type of sensor, and this sensor requires calibration in a hot box or a calibration path. Okay, hopefully that explains how things work, and you can see from the sensor that the sensor is fitted with male pins. Obviously when it's disconnected there's no risk of any short circuit. Thank you. Goodbye.